In this video, we're going to be proving the derivative for the arc of sine function, which is equal to 1 over the square root of 1 minus x squared. In this video, we're going to be doing this through right triangles. In future videos, I will post a proof for this derivative much more in an algebraic manner. But in this video, we're going to be doing it through right triangles. So for starters, we're going to assume that sine of arc of x is equal to y. So by definition, sine of y will be equal to our variable of x. And what we can do is now relate sine of y is equal to x to a right triangle based on the definition of the sine function within a right triangle, which is the sine of any angle is equal to the opposite side of a right triangle over the hypotenuse side of a right triangle. So if we have this right triangle and I assume this angle to be y, that means the side opposite to it will be x and the hypotenuse of this right triangle will be 1. And the third side can be found by squaring the hypotenuse minus the square root of our second side, which is x, minus x squared. And this comes straight out of the Pythagorean property, which says that a squared plus b squared is equal to c squared. To find any of the second sides, such as a will be equal to the square root of c squared minus b squared, the hypotenuse squared minus our second leg of the right triangle squared, hence obtaining the square root of 1 minus x squared as our third side of this right triangle. And what we can now do is take the derivative on both sides of the equation sine of y is equal to x to obtain, by the chain rule, cosine of y times y's derivative will be equal to 1. We can rearrange this to get y prime is equal to 1 over cosine of y, which will also be equal to the derivative for the sine of x, the arc of sine of x function. And the reason why this is because we assumed the arc of sine of x to be equal to the variable of y. Therefore, y's derivative will be equal to the arc of sine of x's derivative. So 1 over cosine y's definition is adjacent over hypotenuse. So based on our right triangle, cosine of y will be equal to the adjacent side, the square root of 1 minus x squared, over 1, which is equal to the square root of 1 minus x squared. Therefore, y prime will be equal to 1 over the square root of 1 minus x squared, whence we simply substitute the cosine of y value into cosine of y, hence proving the derivative for the arc of sine of x function as 1 over the square root of 1 minus x squared through a right triangle.